So listen very carefully and follow the instructions on this mineral property lab, because this lab will be graded for accuracy. It is not just a completion at this point. So if you mess this up, it's going to affect your grade. So you need to work in groups of 4 on this lab. You can maybe get by with 3, but you're going to have to work a little bit more diligently and quickly and carefully. We're not going to do groups of 5, 6, 7. Put yourselves in groups of 4. If you cannot find a group of 4, I will more than happily assign groups of 4 that come out evenly. The trick here is every person in the group is going to have a different column on this data sheet to test. So one of you is going to be testing the streak color, while one of your partners is going to be testing hardness, and another partner is going to be doing fracture or cleavage, and one's going to be doing luster. But as you do this, y'all need to talk to each other. The person testing hardness should get some confirmation from other people in their group. Say, hey, what do you think about this? Does this look like this? Same thing if you're testing luster. Talk to your neighbor. Say, hey, do you think this is milky or this pearly? Or should I call this one earthy? You should be talking to each other constantly. And you each must be doing your own thing in order to get through all of this data today. Here is what your mineral collection looks like. Take a picture of this so that you know exactly which minerals go in which container. You can only pull out one mineral at a time. Do not take these out and set them on the counter, because you will mess up what numbers they are. And just in case, we have a picture that we can kind of put them back in the right place. You take a mineral out, take out number 7, and you're testing hardness. And when you're done testing the hardness of number 7, put it back in the container, and then grab one of the other minerals. You don't have to test them in order. So each person is going to have one mineral out at a time, and you need to make sure which number your mineral is as you test it, so that it goes back in the right spot. Otherwise, it's going to totally skew your results, and you'll fail this assignment. Color. This is the one that you guys can kind of do together, because it's the simplest. Just look at it and have a discussion. Hey, what color do you think this is? Oh, I think it's green, or it's yellow, blue, whatever. This is a very subjective piece of data to record. Don't spend a lot of time on it. First guesses is fine. You don't need to get exact when we talk about color. Now, mineral streak.
So mineral streak is the color of the mineral in a powdered form. And you're not going to take a mineral and try to grind it into a powder. What you do is you use what's called a streak plate. And you take the mineral and you rub it pretty hard across the streak plate, and some of the mineral is going to come off, and we're going to see a residue or a powder, and we're going to be able to know what color it is. So you're going to take a mineral and rub it across the streak plate. You got to push down pretty hard. We have 2 different colors of streak plates, because if it gives a darker colored streak, like a black or a gray, you won't see it on this one, but do it on that one and you can tell. Be careful when you note the color. Just don't say it's all gray or it's all black. Look at them pretty carefully. You might even want to use something like a magnifying glass to compare one streak versus the other and see, hey, that one's a little more gray and this one's a little bit more black. So you're going to test all of these minerals and their streak by rubbing them across the streak plate and see what color streak or residue it leaves behind.
There might be 1 or 2 minerals in there that are harder than the streak plates and will not allow themselves to be scratched into a powder. In that case, you can write no streak. Now, hardness. Hardness is a little more complicated. I'm going to explain this to you. You need to follow along carefully. So if you're the person that's going to test hardness, listen carefully and have this part of the presentation open. Hardness is a range, and what you do is you test hardness versus different materials that are easy to get your hands on and that are known quantities. For example, your fingernail. You're going to pick up the sample of mineral and you're going to try to scratch it with your fingernail. So obviously give this task to someone in the group that's got some fingernails that they can use to scratch. They can be real fingernails or they can be fake. So you rub your fingernail across the mineral. If it puts a scratch into the mineral, like it digs a little groove, that means your fingernail is harder than the mineral. Well, we know that your fingernail has a hardness of about 2.5. So if you leave a scratch in the mineral, that means that mineral's hardness must be less than that, less than 2.5. If you rub your fingernail across the mineral and it doesn't leave a streak, well, that means its hardness is greater than 2.5. You might want to take a magnifying glass and look and see, is there a groove cut into it? Some of these might be kind of hard to see just by the colors. You can look at it closely. Well, if your fingernail doesn't scratch it, if it's harder than your fingernail, it's harder than 2.5, move on. Now we're going to go get a little piece of copper wire. I'm going to take the sharpened edge of the copper wire and we're going to try to scratch the mineral. You got to look at this carefully because, like in this case, we can see that the copper is actually rubbed off onto the mineral. That means the copper is softer than the mineral. So it didn't scratch it. That means the hardness is greater than 3.5 because the copper was harder. Now, if the copper does scratch this, well, that means it's less than the hardness of copper, 3.5, but it was greater than your fingernail. So you would write for the hardness that it is between 2.5 and 3.5. Follow this flow chart and you'll be able to figure out what numbers we rate for hardness. Next, we're going to use a nail. Try to scratch it with a nail. Once again, you're going to want to use the magnifying glass to check this out. Does it leave a groove into the mineral or not? If it does, that means the nail is harder and the hardness of the mineral must be less than 4.5, but it's greater than 3.5. Now, will it scratch glass? Glass is a little different. We don't pick up and hold glass and try to rub it across the mineral because we want it to break in our hands. You're going to take this mineral and you're going to try to scratch it across the glass plate. If it makes a scratch in the glass, well, then it's harder than the glass. Glass has a hardness of 5.5, so we would say the mineral hardness is more than 4.5. This one here did not make a scratch in the glass, so its hardness was less than 4.5. So if it scratches the glass, we've got to keep going. We're going to get a file. And if we're going to try to make a little dig on the mineral with a file and see, does it scratch? If the file scratches the mineral, well, that means the file is harder. The file's hardness is 6.5, so that means that mineral would be between 5.5 and 6.5. If the file will not scratch the mineral, that means the mineral has a hardness of greater than 6.5. And that's kind of the end of the line. That's the last thing that we have that can test the hardness, or the last thing we can use to test to see if it will scratch the mineral. So your hardness values, you're going to have only these answers in the hardness category based on where you end on that flow chart. Cleavage versus fracture. Remember that repeating patterns of flat surfaces is cleavage, and if there is no pattern of flat surfaces, it's fracture, and that's what you're going to mark in this column here. If it does have cleavage, we're going to describe, and this is only if it does have flat surfaces, how many flat surfaces does it have? Cleavage or fracture. Don't get crazy with this. This is very, very jagged. Don't go look for like a little tiny little speck here where, oh, there's a little tiny flat spot there. That must be cleavage. That's not it. This mineral is very definitely fractured. It's very jagged. It's irregular. It doesn't have a regular pattern of flat surfaces. This, however, is an example of cleavage. It's got a flat surface here. It's got a flat surface here. It's also got a third flat surface there. Now the repeating pattern means, think about them being parallel. This flat surface and this flat surface are in the same plane. This one here and this one here are in the same plane. So you'll see repeating patterns of flat surfaces, and that means cleavage. You can see it here. Obviously, lots of repeating patterns of flat surfaces. This is very definitely cleavage. Now, if it does have cleavage, you got to try to figure out how many different directions does the mineral have cleavage in. This one here, this is a mineral that breaks off into sheets. It's flat that way, but notice the sides aren't flat. They're very jagged. So this is an example where it's only flat in one plane or one direction. This is an example, though, where we've got a flat surface here and a flat surface here, and they're at a 90-degree angle to one another. Those are two different planes of cleavage, so it has cleavage in two directions. These all have cleavage in three directions. We've got a flat surface on this side, a flat surface here, and a flat surface here. That's cleavage in three directions. So if it has cleavage, take a look at the pattern. How many different planes of flat surfaces does it have? Basically, the maximum is 3 for what we're doing. Luster. We're going to use these words we had in the presentation that you put in your PowerPoint to describe what does the mineral look like under light. Metallic, if it looks shiny like metal. Glaseous or vitreous means that it's clear or semi-clear like glass. It doesn't have to be totally clear because just like a stained glass window, it doesn't have to be totally clear in order to be glass. Waxy. You know what wax looks like. It's not very shiny, but you can tell the consistency of a wax candle. You know what it looks like under the light. Pearly, though, is a little bit different. Might have some of the same color, but if you hold something like the pearly luster up to the light, it's got a little bit more of a sheen to it, a little bit more of a shine to it. Earthy is the catch-all. It's the everything else. If it's not one of those others, that means it just is called earthy. It's kind of nothing else. Adamantine luster is a word that you have, but we're not going to use in this particular lab because this is reserved for gemstones, things like diamonds. As a matter of fact, it's called diamond-like. So we're not going to be passing diamonds around the room, but just realize that adamantine luster is one of the choices, just not one that we're going to use here. That's the end of our presentation. You're now able to put away your phones and you can get your mineral kit from me and you can begin work on recording the characteristics of the mineral in your kit. When you're done, you need to bring me your data sheet and I'll have it stamped done, and then we're going to put it away and use it for the assessment piece tomorrow.